Okay, so the second to last topic covered is going to be iterators. So the whole idea behind iterators is to create this lazy method of returning elements from an iterable. And we'll talk about what iterable and iterator really mean in just a second, but I just want to first start off with an example. So let's say that I have this array list, and inside I add these integers corresponding to maybe the number of friends I have. And then the original way that you've been iterating through this array list is using a for loop, right? So for this type of enhanced for loop, you just iterate through all the elements in your array list, and then you do whatever work you want to do with them. But this is actually the same thing as this code right here, which is using an iterator. And so more explicitly, you can actually, so what this code is behind the hood doing is it's calling the iterator method of your array list. And then this is going to be turning an actual iterator. And using this iterator, you're going to get the next element in a lazy sort of way, only when you actually need it, right? And before you get the next element, it's really good practice to call hasNext first to make sure that you can actually get that there's actually a next element to return, because otherwise you're going to run into some kind of an exception, right? Okay. So the first thing that you really want to recognize is that these are different, right? So friends, which is an array list, a type array list, is really more of an iterable, right? Iterable is something that you can iterate over. So everything inside collections, right? Array list, linked list, even, as you will learn, hash maps and stuff like that. These are things that you can iterate over. Whereas the iterator is actually doing the job of iteration, okay? And these two correspond to their own interface. And so iterable is an interface where you have this one method, iterator, right, which returns an actual iterator, which is going to then be used to iterate over your iterable. Okay, so notice that you have these two combinations. So I color coordinated all of these. So iterable is green, iterator is yellow. And so inside this iterable interface, you actually need to call this iterator method, which will return to you the iterator object you'll be using to actually do the iteration. And then for your iterator interface, you have all of these different methods that you can potentially implement. Basically, the two main ones that you need to care about are hasNext and next. You can decide to override or create your own implementation for remove and for each remaining. But basically, these are default methods, right? In other words, it has a default implementation, and you don't really need to care about them for this class. But what does hasNext and next do? hasNext is a Boolean return type. So it returns true if and only if there is something else remaining in your data structure, right? If you don't have any more element left, then you're going to be returned false. For next, it's going to return the next item in your data structure. And only one item gets returned per call. And so you cannot, for example, call .next and expect more than one item to be returned at once. And you can also not expect to call .next and then try to retrieve the object that you just got returned by calling some other .next again, right? So .next is only a one direction call. It only goes through your data structure forward. It does not allow you to go backward and retrieve something that you've already been returned. All right, so now what is the purpose behind having these two separate interfaces? Why can't we just have one of them? This is the same idea as with comparable and comparator, and notice that they even have the same suffix, right? So the idea behind comparable and comparator is that comparable defines a natural ordering. A natural ordering is kind of, let's say for integers, right? A natural ordering would be based on their numeric value. A comparator, however, allows us to define an ordering that's different from the natural ordering. So for example, we could reverse order the integers, right? We could say, okay, I want all the small numbers to come first rather than in increasing order. And so comparators allow us to define other orderings. It allows us to basically flexibly specify some ordering that we want to do rather than what is considered natural or what is the kind of the default implementation. And so the same thing with iterable and iterator. Iterable allows us to just iterate over something if there's really no other way, no other flexibility. Whereas for an iterator, we can determine how we do things, right? And so we can determine that instead of actually returning the forward item in our data structure, we can actually, maybe flip our data structure and then return things in reverse from backwards to forwards by, first sorting our data structures so that everything is in reverse. So we can do all these cool things with an iterator, and the comparable and the iterable is what is kind of the, I guess, yeah, the one way kind of model. And so if we look at an example of an implementation, first you need to import java.util.iterator, and then this is actually taken from your lab. So remember that if you want to create an iterator implementation, then you want to always actually implement the iterable interface. And inside this iterable interface, you're going to have this iterator method, because remember the iterable interface has this iterator method. And this iterator method is going to return a new iterator. And this new iterator is going to be based on your private nested class. And this private nested iterator class is going to implement this iterator interface. And this implementation is going to include the implementation of next and has next. Okay, so in this case, I guess we're looking at some, so our values is going to be our iterable, and then we're keeping track of where we are in the values. So the bookmark is kind of the place that we're at, the index that we're at in values. And then notice that an important thing about next is that before we actually return the next item, we want to increment this value first. Okay, because otherwise, if we just return before we increment, then we're actually not doing any updating to the index, right? Okay, so here's a practice example. So from summer 17, midterm 2, question 1, this is on tau beta pi. Basically, I hope you had an opportunity to look at this question, but a nested list is a list that contains either a character or a list of nested lists. And so something that looks like this, right? Where the brackets denote a nested list, and then parentheses denotes a list. And so given this, you want to complete this deep iterator interface, this deep iterator class, which implements this iterator interface, so that you can return each character in your nested list in order, whether they're nested or not, right? So it's kind of cool what you're going to be doing. Given this type of nested list, a series of next calls should just return the characters inside your list. So E, X, and O. And so even though a nested list can be arbitrarily deep, you only care about returning the actual character. So how do you do this? Well, this is actually going to be using stacks. And so remember, a stack is like a stack of pancakes, right? So the most recent pancake you've made is going to go on top of the stack. And when you take off a pancake, you're taking it off of the top of the stack, right? And so this is really a first in, first out data structure. Okay. So given all these helper methods, right, is character returns true if this nested list holds a single character. In other words, if this nested list only consists of a single character, otherwise false. And get character is going to return this single character that this nested list holds. You probably want to call is car before you want to call this method. And then get list is basically going to do what get car does, except for a list of nested lists.